Hello, everyone. Welcome to the DI 101 webinar series. My name is Jared Evans, and I'm the Director of Marketing for Distribution International. If you are new to the DI 101 webinar series, I will tell you that it is an incredible resource offered to DI customers, partners, and associates. By partnering with our manufacturers and our industry experts, these webinars deliver informative presentations about industry trends, new technology, new products, and product applications. In order to fully support our customers, Distribution International offers products and solutions from multiple manufacturers and brands in many product categories. This webinar does not represent an endorsement of one manufacturer or brand over another. We pride ourselves in partnering with manufacturers that deliver products of the highest quality to our customers. Today, we're extremely excited to welcome our strategic manufacturing partner, Owens Corning, for today's webinar presentation. Let me introduce you to our presenters. We have Alec Cusick. He's with in the Industrial FOAMGLAS division at Owens Corning. He is the Technical Services Engineer. Prior to his current role, Cusick was in technical sales for fiberglass and mineral wool mechanical insulation with Owens Corning. He serves on multiple technical committees, including ASHRAE and NIA. Cusick is an ITC Certified Level 1 Infrared Thermographer and a NIA-Certified Insulation Energy Appraiser. He holds a degree in mechanical engineering from the University of Toledo. Go Rockets. We also have Doug Fast. He is Owens Corning's industrial mineral wool professional engineer and technical leader. Doug has more than 20 years of experience in the insulation material industry, working in product testing, technical services, and new product development. He has a working knowledge of materials such as foam plastics, fiberglass, and mineral fiber, as well as other traditional high temperature insulations. Doug has contributed to the industrial insulation industry through participation with ASTM, as well as technical education in the form of technical bulletins, blogs, podcasts, and webinars such as today related to topics such as acoustics, moisture, corrosion under insulation, and personnel protection. We're proud to have these two guys from Owens Corning present today, and we thank them for their time. We will field questions at the end of the webinar. To submit questions, please use the questions tab on the GoToWebinar control panel. You can submit your questions at any point during the webinar just by typing out the question in that questions tab, and we will answer the questions during the question period at the end. Without further delay, I will turn this over to Alec and Doug with Owens Corning.
Thank you very much, Jared, and thank you again to DI for the opportunity to be a part of this ongoing webinar series. Without further ado, we'll move forward into the topic of today, which will be passive fire protection systems in industrial applications. I'd like to go ahead and just set the agenda for what we will be talking about here today. We'll start off talking a little bit about Owens Corning for those that may not be familiar with us as a company. We'll then move into common methodology around fire safety and passive fire protection in general, followed by some common standards that can be referenced and utilized within the industry. We'll then talk about some key things you may want to keep in mind when discussing your material selection for these systems, as well as some specific fire tested systems that we at Owens Corning have tested ourselves. And then we'll wrap things up at the end by discussing some technical resources that we also have available. Starting off, Owens Corning is a global industrial and building materials leader with 3 integrated businesses dedicated to the manufacture and advancement of insulation, roofing, and fiberglass composite materials. We have over 19,000 employees that operate across 33 different countries around the world, and we are very proud to have been a member of the Fortune 500 company list for the past 66 consecutive years. Owens Corning offers a wide portfolio of insulation products that can be utilized in many different areas within modern industrial facilities. These systems can be designed to serve a multitude of purposes, including passive fire protection, energy efficiency, and sound isolation, just to name a few. Our product portfolio includes both open and closed cell insulation solutions, including FOAMGLAS cellular glass, fiberglass, Paroc and thermofiber mineral wool, and FOAMULAR extruded polystyrene. With that being said, I'm going to turn the mic over to Doug as he discusses some common methodologies around passive fire protection in general. Doug?
Thank you, Alec, and thank you everybody for taking time out of your day to come and listen to Alec and I present this very interesting and I think valuable topic. To start off with, it might sound strange to talk about thermal insulation and passive fire protection in the same sentence, but since insulation reduces the rate that heat can transfer into process equipment or into structural elements, it becomes more apparent that insulation can also serve as passive fire protection. There's a common misperception that insulation blocks the amount of heat that can pass through a given material. Insulation actually slows the rate that heat energy passes through a given material. In the case of passive fire protection, the goal is to reduce the rate that heat enters piping equipment and structural elements. When this is done, process elements will take longer to heat up and vent, which is a good thing, and structural steel maintains its strength for a longer period of time, delaying catastrophic failures. This allows for a better chance of shutting down the equipment in a safe manner and provides more time for firefighting personnel to arrive. Incidents, while uncommon, still occur and can be catastrophic. Some recent examples are Piper Alpha circa 1988 in the North Sea and the Deepwater Horizon disaster of 2010 that occurred in the Gulf Coast of the United States. Next slide, please. Here are a few examples of facilities that are best served with passive fire protection. Essentially, any facility that stores and handles flammable materials and potential combustible sources. Large amounts of potential fuel coupled with complex equipment and piping highlight the need for passive fire protection. As you can see in the images shown, a fire at any one of the pipes affects the equipment in that area, potentially causing a cascade effect. When we look at the potential access, if we have a fire in some of these facilities, the need for additional time becomes apparent. Next slide, please. So within different facilities exist various types of equipment to be insulated, many of which require passive fire protection. As we mentioned earlier, insulation protects against rapid temperature rise by slowing the rate that an insulated substrate or structural element heats up. This provides more time until venting of the process elements such as pipes, tanks, and vessels. Allows for a safe and controlled shutdown of process equipment. There's also more time until structural steel reaches 1,000 degrees Fahrenheit, where it loses a considerable amount of its strength, approximately 50%. That helps to maintain the structural integrity for a longer period of time. If we were to leave these assets uninsulated, the temperature would rise more rapidly, shortening the time to failure. Additionally, rapid temperature rises in process equipment can result in explosions. Imagine if the leg and the sphere shown in the bottom corner of the slide were to be compromised. The contents would add to the fire and the sphere's integrity if it were to be compromised. Some of the sources of ignition that could potentially ignite flammable gases or liquids in these environments include the following: welding, electrical malfunction, static electricity, lightning, test equipment, auto ignition, and loss of control of equipment, as well as absorbent insulations. Should the unthinkable happen when a flammable material meets an ignition source, plans must be made to minimize damage to the asset and, more importantly, safety to the facility personnel. Now we'll turn it over to Alec, who's going to tell us more about fire standards and testing.
Thank you, Doug. One standard commonly referenced when designing passive fire protection systems is UL 1709, the standard for rapid rise fire tests of protection materials for structural steel. This test evaluates the ability of protected materials, such as insulation systems, to withstand high temperatures and protect equipment and process lines in the event of a fire. It was originally designed for use on structural steel, but has also been adapted over the years to cover protection of process piping, equipment, spheres, tanks, and vessels. The test involves attaching a group of thermocouples to a steel substrate and then covering it with the protective system in question. The system is then placed into a furnace and brought to 2,000 degrees Fahrenheit over a 5-minute heat period. The test continues until a group of thermocouples underneath is allowed to reach an average of 1,000 degrees Fahrenheit, or a single thermocouple reaches 1,200 degrees, at which point the test is concluded and the time rating is recorded. Here we have a visual representation of 3 hypothetical pipes, all covered with different insulation systems being tested in this manner. As you can see, in 5 minutes, the furnace reaches 2,000 degrees Fahrenheit. The thermocouple groups underneath the insulation are then monitored throughout the test. Whenever a thermocouple group reaches the 1,000 degree limit, or if a single thermocouple reaches 1,200 degrees, the system fails and the time rating for that system is logged and recorded. In this example, system 1 would have a time rating of just over 30 minutes, system 2 just over 45, and in system 3 it would be just over 60 minutes of time rating. Another test method commonly used in the industry is ISO 22899, the determination of the resistance to jet fires of passive fire protection materials. This test method measures the resistance and protection provided by protective materials to the high velocities and temperatures associated with jet fire scenarios. It is used on structural steel as well as process piping equipment, tanks, and spheres, and is frequently used in hydrocarbon processing facilities to help protect these systems in the event of a breach of a high pressure line, which can result in a high velocity flame. In this test, a steel substrate is once again attached with thermocouples and then covered with the protective system to be tested. The system is then exposed to a high velocity flame and allowed to heat up until a single thermocouple underneath reaches 400 degrees Celsius above ambient conditions at the start of the test, at which point the test is concluded and the time rating is recorded. Once again, we can see 3 hypothetical systems being tested in this manner. Immediately upon starting the test, the system is exposed to a high velocity jet fire and the thermocouples are monitored. The systems are allowed to heat up until one thermocouple climbs that 400 degrees Celsius above ambient conditions, at which point the test is concluded and the time rating recorded. In this example, system 1 again would have a time rating of just over 30 minutes, with 2 just over 45, and example 3 just over 60 minutes of protection rating. Another consideration to be made when designing passive fire protection systems is the impact that systems may have on the sizing of relief valves. In hydrocarbon facilities, materials must frequently be kept at low temperatures in order to keep them stored safely in their liquid form. In many cases, depressurizing systems must be incorporated into storage tank designs to allow for the safe relief of pressure buildup due to vaporization in the event of a fire or other failure. Passive fire protection systems offered by insulation may be considered when determining the size required for these relief valve systems. There are multiple standards that provide recommendations for the design and structure of these pressure relief systems, including API 2000 and NFPA 30A. These standards contain equations for thermal credit taken for insulation systems, which restrict the flow of heat into a vessel in the event of a fire. Once again, passive fire protection systems may be considered in determining the relief valve sizing requirements for storage tanks in these critical low temperature processes. I'll now hand it back over to Doug as he discusses some common industry practices around material selection.
Thank you, Alec. There's several different ways that passive fire protection can be used. One is to use the insulation itself, and at a minimum would include insulation and jacketing. In some cases, you might use an intumescent coating, which is a material that chars and expands to form a type of insulative layer to reduce the rate of heat transfer, which again slows the rate that the substrate heats up. This is very similar to those little snakes that you have in your fireworks kit where you light and that little charcoal thing expands. It's very similar to that effect. Or you can also have a hybrid system where you're actually using the insulation, the jacketing, and an intumescent coating to all be able to treat that element or piping structure to extend the time that you had to deal with the fire. Now, it has to be noted that in many, if not all cases, the insulation system will be sacrificed in the event of a fire. Insulations can melt, crumble, or be stressed beyond its intended use. At a minimum, the system would require a complete inspection before returning to use with the new passive fire protection system. Next slide, please. So when we consider materials to use for passive fire protection, the first thing to look at is how the material performs when tested to some common fire testing used in the industrial space. First, we talk about combustibility. It's commonly referred to in industrial insulation data sheets, and this is the tendency of the material to burn or contribute to the fire as fuel. Ideally, we want an insulation that does not lose its mass or increase the temperature of the fire or exotherm as it heats up. ASTM E136 and ISO 1182 test methods are typically used to measure combustibility. Next, we talk about flame spread. which helps to determine how far and how quickly a flame will propagate across the surface of a material when it's ignited. Ideally, we want something where the flame doesn't spread or it spreads very slowly in a given period of time. ASTM E84 or CAN ULC S102 is used to measure flame spread. And finally, we have smoke development, and this is a measure of how opaque or dense the smoke is that is generated by material as it's being evaluated for flame spread. The higher the smoke density, the lower the visibility, and the greater the danger of smoke inhalation to firefighters and surrounding personnel. Ideally, we want a material with low smoke development. The measurement of smoke development is done with ASTM E84 or CAN ULC S102, and it's measured simultaneously with flame spread measurements. Next slide, please. So there's some additional key properties here that you need to look at to see how the material is going to perform when it's tested as some common fire tests used in the industrial space. Thermal conductivity is a material property which describes the rate at which heat passes through a given material. The lower the thermal conductivity, the longer it takes for heat to pass through a given material. Ideally, we want a material with a low thermal conductivity. We want that not only for passive fire protection, but we also want that for all the reasons that you would use insulation, such as personal protection, process control, etc. The next thing we want to look at is specific heat or specific heat capacity of material, which is the energy required to raise the temperature of a unit mass of material of a given substance by a given amount. The specific heat of water is 1 BTU per pound per Fahrenheit degree, whereas steel is along the lines of 490 BTUs per pound per Fahrenheit degree. Generally speaking, the heavier material, the more energy it takes to heat it to a given temperature. If you've ever tried to cook with a cast iron skillet versus an aluminum pan, you'll notice it takes much longer for the cast iron skillet to heat up. And so that's important when we're looking at something that we're going to be putting into service as a potential passive fire protection. Then finally, we have service temperature, and this is the maximum temperature that material can safely and effectively function. And that's typically listed on data sheets for both mechanical and industrial installations. The surface temperature is typically defined by the manufacturer and test methods such as ASTM C411 and C447. And it may differ by the end-use application. Exceeding the maximum service temperature can permanently change the material properties by causing degradation that could include shrinking, melting, warpage, or just overall deformation of the product. And so again, as we said earlier, in many cases, if you're using an insulation in a passive fire protection system, oftentimes it will need to be replaced because it's generally going to be heated beyond its maximum service temperature. Next slide, please. So now we're going to talk a little bit about Owens Corning insulation systems for these applications. So first of all, we have our mineral wool insulation, which is comprised of inorganic fibers made from rock or and recycled slag. Has excellent thermoacoustical properties. Has a maximum surface temperature of 1200 degrees Fahrenheit and flame resistance up to 2000 degrees Fahrenheit. And just a little bit of clarification, as we just talked about maximum use temperatures or service temperatures, the product is very stable up to 1200 degrees. The fibers don't start to melt until over 2000 degrees, but again, you're going to have some degradation in the performance of the product, but the material does remain intact. So with that, we're going to move on to Owens Corning mineral wool products. Specifically, we have our Thermofiber Pro Section WR pipe insulation, which is water resistant, comes in 4-foot lengths for productivity, and it's also ISO 15665 compliant for use in acoustic applications. We also have our Thermofiber industrial board. It's available in densities ranging from 4 to 15 pounds per cubic foot, and it's easily fabricated for multiple applications, including pipe and tank wrap or for insulating larger, flatter surfaces. So with that, we're going to turn it back over to Alec, who's going to tell us more about Owens Corning FOAMGLAS insulation and its use in passive fire protection applications.
Thank you, Doug. Starting off, just to cover it for those that may not be familiar or have worked with it before, what is FOAMGLAS cellular glass insulation? Well, it's a lightweight, rigid material composed of millions of completely individually sealed glass cells. Its closed cell structure and inorganic nature do lend to some unique properties amongst insulation materials in the industry. And it also does boast a wide surface temperature range as a thermal insulation from -450 to +900 degrees Fahrenheit. Although, as Doug pointed out on the last slide, there's a difference between surface temperature range and temperature range that a material may continue to provide protection in the event of a fire. So while it's designed to be used in service up to 900 degrees, the material will in fact remain in place and offer fire protection at temperatures higher than that in the event of a fire. FOAMGLAS is completely impermeable with a water vapor permeability rating of 0. It does not require the use of an external vapor barrier to achieve this, as the insulation itself acts as its own vapor barrier. It also boasts a relatively high compressive strength when compared to other insulation materials in the industry, making it suitable for both direct buried and pipe support applications. It's also very dimensionally stable, having a thermal expansion coefficient similar to that of carbon steel, making it suitable for wide temperature cycling applications. Being 100% inorganic and made of glass, FOAMGLAS is also non-combustible and does not give off dangerous gases in the event of a fire, making it suitable for fire protection and fire stop applications. It also is resistant to the nesting activities of common vermin that may be found in an area, and is chemically resistant in a similar fashion to many typical glass beakers that you might expect to find in a laboratory environment. Finally, it's easy to cut and can be prefabricated to many different shapes and configurations prior to arriving on job site. We at Owens Corning also offer a full portfolio of FOAMGLAS accessories to be incorporated into these insulation systems. To name just a few, these include pit seal sealants to ensure a proper seal against vapor intrusion on below ambient systems that would be suitable for the joints in between sections of FOAMGLAS. We have PC adhesives for securement on certain and irregular substrates, and pit wrap jacketings to provide weather and freeze thaw protection for the surface cells of the FOAMGLAS insulation. With that being said, we'll now get into some of the specific insulation systems that Owens Corning has tested for passive fire protection applications. Before we continue, I do want to outline some of the information that you may see on the coming slides. Within the tables present, you'll see which test method was used for the system in question, the time rating that can be expected for that system, and some common areas to specify that system, including process temperature ranges, types of equipment, and examples of relevant industrial facilities that it can be found within. Additionally, at the bottom, you can see an outline of the system makeup itself, including the insulation materials and accessories used. One thing I'd like to mention is that the time rating shown for each may vary with substrate size, geometry, insulation thickness, and process temperature. So it's always a good idea to take a look at your individual application, and we'd be happy to help pinpoint exactly what type of protection we'd be able to offer for your specific application. Here we have our first example of a fire tested system by Owens Corning. This system was tested in accordance with UL 1709 with a time rating of up to 30 minutes. This is a common system that you can find on below ambient, near ambient, slightly above ambient applications for piping equipment, tanks, vessels, structural steel, commonly found in oil and gas processing and petrochemical facilities. The system itself includes FOAMGLAS 1 insulation in a single layer configuration with our pit seal sealant, pit wrap jacketing, and 016-inch stainless steel cladding over the top. Here's another example. It's actually very similar to the last one we just showed, although this one incorporates an additional layer of ceramic fiber insulation above the initial layer of FOAMGLAS. This was again tested to UL 1709 with a time rating of up to 120 minutes. Similar applications can be utilized on below ambient, near ambient systems, commonly found in oil and gas processing and petrochemical facilities. Here's an example of one of our systems that utilizes adhesive. Here is a system that because of the use of adhesive, can be applied to a wide array of substrates and geometries that may otherwise be difficult to insulate. So that could be piping equipment, tanks, vessels, spheres are a big application for this. Again, the use of adhesive means that with the difficult nature of a sphere being hard to mechanically secure, you can utilize one of our adhesives and make sure that the insulation is staying in place on your application as long as it needs to. This specific system in question includes our FOAMGLAS 1 insulation in a double layer format this time, with one of our PC adhesives and 016 cladding over the top, again with a time rating of up to 120 minutes. Here is the same exact system that we just went over, but I did want to point out that another common application for this would be on structural steel and steel I-beams. Again, due to the irregular nature of this type of geometry, as long as you have foam glass that's been prefabricated appropriately to fit to whatever geometry you have on site, it's as simple as using one of our appropriate adhesives and getting a tight fit and securement on the actual steel substrate itself. And in this example, due to the different nature of an I-beam geometry as opposed to a pipe, which was tested last time, this specific system was tested to UL 1709 for 180 minutes of protection. Here's an example of one of our more niche insulation systems. This is an example of our acoustic insulation system. So by pairing foam glass with the acoustic performance of our mineral wool insulation, you're able to achieve a system that can withstand vapor intrusion via the foam glass jacketing and accessories, but also provide some acoustic performance to your system, maybe for applications where you have noisy pipes or equipment that you're trying to mitigate sound escaping from. This system consists of our FOAMGLAS 1 in the double layer format, again with our pit seal sealant, pit wrap jacketing, and then insulated with our Owens Corning mineral wool pipe insulation with mass loaded vinyl layers incorporated into it. Followed up at the end with 016 stainless steel cladding. This system can get you a time rating of up to 180 minutes when tested to UL 1709. And in addition to everything we just said, we also have systems that are exclusively utilized for mineral wool applications. Here is one of our mineral wool insulation products tested to UL 1709 with a time rating of up to 90 minutes. This is commonly found on above ambient applications, piping, equipment, structural steel, tanks, vessels, very frequently found in oil and gas processing, petrochemical, and power plants. And it's a simple system of our Owens Corning mineral wool pipe insulation with 0.6-inch stainless steel cladding over the top. Now we'll get into some of our systems that were tested not to UL 1709, but to ISO 22899, aka the Jetfire scenario test. This system is a single layer of our FOAMGLAS 1 insulation, again with pit seal sealant, pit wrap jacketing, and this time 0.27-inch stainless steel cladding. This was tested to a time rating of 30 minutes and can be found on similar scenarios to what we've been talking about. Anything from below ambient to above ambient, any piping equipment, storage tanks that you might have, commonly found in oil and gas processing. Again, here's a similar system to what we just went over, this time incorporating an additional layer of ceramic fiber insulation in addition to the foam glass. Similar to the previous Jetfire scenario, you want to incorporate 0.27-inch stainless steel cladding as your final layer on the outside. And this specific system was tested to the Jetfire standard for up to 90 minutes of protection. Here is the same acoustic system that we had just talked about for hydrocarbon, and we've also tested it in accordance with ISO 22899 for Jetfire applications. So again, this system utilizes our foam glass insulation in combination with our mineral wool insulation to provide below ambient performance that also offers acoustic sound isolation with 0.27-inch stainless steel cladding. And this system was tested with a time rating of up to 120 minutes of Jetfire protection. And here's one example of one of the hybrid systems that Doug had brought up previously in the presentation. Again, this was tested to the Jetfire test method with a time rating of up to 240 minutes. This can be used on below ambient applications, above ambient applications, applications where thickness might be hard to come by because of the inclusion of that intumescent coating over the top. The system itself is very familiar with what we've been talking about. FOAMGLAS 1 insulation in a single layer format with a PC adhesive, one of our FOAMGLAS adhesive products, pit wrap jacketing, and this time it utilizes a Pitchar NX intumescent coating and a carbon mesh over the top. And this system relies on both of the best worlds of these products, an insulation system to reduce heat flow, and intumescent coating to expand in the event of a fire and provide a thick layer of passive fire protection over the top of the insulation. Now I'd like to wrap things up just by covering some of the technical services and resources that Owens Corning does have available. For those that are interested in specific systems that we've discussed today, we do have third-party test reports available from laboratories where these tests were conducted. These reports cover the test procedures, system configurations, as well as detailed results. Additionally, we also have Lloyd certificates available for those systems that were specifically tested for performance against jet fire scenarios. Here at Owens Corning, we also offer fire modeling and thermal calculation services to help in the design and selection of passive fire protection systems. These reports can help specifiers determine the appropriate system configurations to achieve the fire protection performance that they require. This goes back to what I was talking about earlier with different sizes of substrates, different materials utilized underneath, whether or not a given pipe is filled with a fluid or assumed to be empty. Those are all things that can impact the types of materials you should be considering, and as well as the type or the duration of fire protection that you could expect. So this is something we'd be happy to work with you on specifically to take a look at your application. In addition, we do maintain and utilize a full suite of proprietary thermal calculation software to help in the aid and design for those who specify any of our insulation systems. If you have questions as to what insulation thickness or jacketing material you need in order to achieve a certain surface temperature, if you're curious about cost savings potential, or have general questions about process control, we'd be happy to assist with a thermal calculation report tailored to your specific system. We maintain over 125 different commercial and industrial insulation system specifications. These guide specifications can be used as a guide for engineers, specifiers, contractors, and facility owners for the design, installation, and maintenance activities regarding all these different insulation systems that we do offer. They include products used, detailed drawings, and installation guidelines. And we also are happy to help review client specifications. If interested, please reach out to us and we'd be happy to have a conversation with your specific specification and see if there's any instance in which we could offer insights or guidance as to how you may incorporate fire protection into them. Here's an example of one of our detailed drawings that we offer. This one specifically is for our adhered FOAMGLAS system for passive fire protection. We generate drawings like these regularly to help bridge the gap between specification and field installation. And we do this to help increase the confidence level that proper application techniques are being utilized on site, and you can be sure that you're getting a properly installed and best designed system at the end of the day. We also provide on-site support around process improvement and energy savings. We have multiple certified thermographers on our staff, myself included. We can arrive on-site to perform an infrared inspection survey and conduct heat flow measurement and analysis on your equipment. We can then issue a current insulation condition report, which we evaluate energy losses and savings potential and provide any advice available on insulation system improvements that you may want to consider for your existing system. Finally, we are seen as the industry leader in education, training, and startup support. We hold frequent training sessions that allow us to build relationships with our customers through shared experiences. These allow engineers and specifiers to become more familiar with our systems, and they allow contractors to better understand how to effectively install them in order to achieve the best performing system possible. Here you can see one of our global training centers located in Houston, Texas, where we frequently host these training opportunities. Please reach out to us with any interest on how we can collaborate with you and your team. And with that, I'd like to thank everyone for joining us here today. And thank you again to Distribution International for the opportunity to be a part of this ongoing webinar series. Myself and Doug's email addresses can be seen listed below, as well as the phone number and email address to our technical services and training team. Please feel free to reach out to us with any questions you may have down the road. And with that, I'd like to hand the mic back over to Jared.
Thanks, Alec and Doug. While we're waiting on a few questions, I want to take a second to remind everyone about the resources available on our website. It is now a robust digital customer platform. DistributionInternational.com has a wide range of value-added features, including our customer portal called Customer Connect. You can view past invoices, request quotes, and even submit orders all online. Maybe the best feature is a detailed outline product catalog of more than 30,000 products that is easily to search and easy to navigate. Go to distributioninternational.com today and register for your online account to make your job easier. Also, you can follow Distribution International on LinkedIn and in YouTube to see more webinars like this that we've saved through the past. So now I'm going to open it up to some questions. We do have one submitted, and this was submitted during while you were going through some of the examples of the system tests you've had. And the question was around when you add adhesive to the system, doesn't that take away from some of the smoke and flame spread and increase the flammability?
That is a great question. So it is no secret that adhesives utilized with these systems do contain a small amount of organic material that is considered separate from the insulation itself. It's not uncommon to see some smoking or off-gassing in the event of a fire for these systems. And in fact, when observing these systems being tested, we do expect to see some gassing escaping during the heat up period of the test itself. However, in the grand scheme of things, given the amount of shear material and the mass of the insulation that takes up over the pipe, the adhesive being used is relatively insignificant when compared to just how much insulation is on the pipe. So it's certainly not enough to overcome the inorganic nature of the insulation itself, and it doesn't contribute any additional heat or risk to spread the fire accordingly. The only instances in where you'd see the adhesive off-gassing are in the small joints between the inorganic insulation sections themselves. So that is a great point. If you were in the situation where you had to utilize an adhesive to secure your insulation, that's something to consider. But in the grand scheme of things, if you're in the event of a fire scenario, worst case scenario that we're talking about right now, it's nothing to be concerned about in terms of propagating the fire further than it would be, given the fact that the insulation itself is what takes up a large majority of the mass and material.
All right, I don't have any questions waiting. If anyone has an additional question, please submit it and we'll get it asked out there for you. We'll give it a few minutes, and if not, we'll wrap up. All right, looks like the presentation was pretty inclusive. As Alec and Doug have put up their contact info out there, I'm sure they'll be happy to take any questions you have offline if you reach out to them. Thank you for joining the DI webinar this week. And please join us next time. Follow us on LinkedIn so that you can see what the next topics will be and join anything that seems interesting. Thank you very much. Everyone have a good day.
Thank you, Jared. Have a good afternoon.
Thank you.